it's the time of Davide Fugazza that will give us a description of another emerging phenomenon which is affecting glaciers, increasing their diminishment. Davide will give us an overview of darkening. Darkening is really a big problem for snow and glacier worldwide. So, Davide, it's your time.
Thank you for the introduction.
Questo vai avanti e indietro.
Okay. Let's see if this works. Okay. Thank you. So we are used to thinking of glaciers as white and immaculate, but this is often not really the case. So these are some pictures of glaciers that I've visited this summer throughout the Alps. You have Pasterze Glacier, which was mentioned before, Morterac, Forni Glacier, as well as a small glacier in the Italian Alps, and you see they all have something in common. They don't look so white. It's not just an aesthetic problem. The point is that the darkening of glaciers causes a reduction in the albedo, and which eventually leads to more melt. So the albedo is the ability of a glacier surface, but just any surface, to reflect the radiation coming from the sun. So a higher albedo means more radiation is reflected. A lower albedo means more radiation is absorbed, and so eventually more melt. Fresh snow has a very high albedo. Then you have glacier ice, which is about a third. And if the glacier ice is dirty, then it has an even lower albedo. The albedo is also involved in a feedback cycle. So if you have impurities in the snow, this leads to a lowering of the albedo, to more melt. And then if the snow melts, then on a glacier, the bare ice surface underneath the snow is uncovered. And then this leads again to more melt because ice has a lower albedo compared to snow. There are different types of impurities which can darken the surface of a glacier. The one that we are perhaps most familiar with, that is actually more visible, is debris cover, which is the one on the top left. Debris cover mostly comes from rockfalls originating from the valley walls surrounding the glaciers. It is accumulated on the glacier surface, and it is then transported on the surface and through the glacier until it reaches the front, which is the area where the glacier melts the most, the ablation area. Now, debris cover is not just a problem for inventories, as we've heard before from Frank Paul, but it's also a problem because even though it definitely darkens the surface, it does not necessarily mean more melt. There have been a lot of studies that have looked at the relationship between the thickness of the debris cover and the melt of a glacier, because once a critical level of thickness is reached, then there is an insulating effect of the debris, and then actually melt is reduced. And so, summarizing our knowledge on debris cover, we can say that if the cover is very sparse and thin, then the albedo lowering effect prevails, and then the glacier surface melts more rapidly, whereas if the debris cover is thick and continues, then the insulating effect prevails. Apart from debris cover, there are many other types of impurities that can be organic or inorganic in nature, and that can be local or also be transported from faraway location. This is the case of dust that can come from deserts. The organic ones include black carbon, which is the product of combustion from diesel engines and also wood fires and industrial activities. And then we also have living organisms and vegetation that can be found on a glacier. Speaking of living organisms, one that has received a lot of attention recently is algae. Algae have been found on Greenland, they have been found on European glaciers. They are known to lower the albedo because they reduce the reflection of radiation in visible wavelengths through their photosynthetic activity. Now, looking at darkening in different areas of the planet, Greenland is one of the first places where the darkening of the ice sheet was studied. And there was a study that came out in 2016 that looked at the record of satellite data and showed a decrease in the albedo, so a significant darkening of the surface from the 80s to the present. Darkening is particularly intense in what is called the dark zone of Greenland, so an area across along the margin of the ice sheet where there is intense darkening taking place. And initially it was thought that the darkening was caused by accumulations of dust and black carbon, but it was later revealed, and this is our knowledge now, that it's mostly algae causing this. And studies have showed that algae contribute to more than 10% of runoff of the Greenland ice sheet. And they also explain much of the variability in the albedo that we see along the margin. Algae have also been found in Antarctica, at the periphery of Antarctica, and there have been a couple of studies which have looked at the role of green versus red algae. So the green ones cause a larger reduction in the albedo compared to the red ones. And also another interesting study that tried to classify the different types of impurities that darken the surface through satellites. So algae compared to black carbon and dust. This is something that we definitely, we need more of these type of studies. In other regions of the world, it's not algae that are the main cause of darkening. For instance, in Central Asia, there have been some studies looking particularly at the Tian Shan region, which have showed anomalous darkening of glaciers in their accumulation area. So the upper part of the glacier, where there is more snow and less melt, and not so much darkening is supposed to take place. And these studies have identified black carbon as the main cause of darkening there. In South America, in the Andes region of Chile, there was an interesting study that showed that there it's not impurities, it's not algae, it's not black carbon that are causing the darkening, but it's the albedo feedback itself. So because there have been some very dry years, including 2020, less snow cover, and then the ice surface is exposed more and there is more melt and a lower albedo. And then we come to the European Alps, which is the area where we also conducted some studies. There have been some interesting studies looking at darkening from different perspectives. And there was one that identified for the first time glacier algae on Morteratsch Glacier in Switzerland. Another study that looked at Swiss glaciers and saw a decrease in the albedo in their ablation area from satellite data. And then we, at the Department of Environmental Science and Policy at the University of Milan, we looked at the Orte-Cevedale group in the Italian Alps and used the satellite record from the 80s to the present and showed a decrease in the albedo, so a significant darkening in almost all the glaciers that we studied. And now we are conducting another study looking at all alpine glaciers from another record of satellite data from the 2000 to the present, and 70% of the glacier appear to have a significant decrease in summertime albedo. So again, a significant darkening. So I would like to also try and answer the question of whether the darkening of glaciers and ice sheets is caused by humans. And I mentioned different processes at play: black carbon, algal blooms, debris cover. Now, black carbon can be from natural sources, so from wood fires, and also from human sources, traffic, industrial activities. And there was a study in Central Asia which showed that 80% of the black carbon reaching glaciers was from human emissions. So this is most likely caused by humans. The other processes, like the increase in debris cover that has been reported on glaciers, is a natural process by itself, and also algal blooms are natural processes. But there are studies that show that also these processes are favored by the higher temperature. For instance, the increase in debris cover is favored by higher temperatures, which cause glacier retreat. So more rock surfaces, nunataks inside the glaciers are exposed, and also permafrost degradation causes the disgregation of rocks, which increases the input of debris to the glacier surface. And the algal blooms are also favored by the deposition of other light-absorbing impurities in another feedback cycle, which is called the bioalbedo feedback, which also then increases the density of algae on the surface. So to conclude, I would like to actually point out what's missing in our knowledge. So we need to better quantify darkening in different glaciers and ice sheets, different parts of the world. And we need to better discriminate between the different components, so the different types of light absorbing impurities that are causing darkening. One thing that we definitely need then is to know whether the debris cover on debris cover glaciers is increasing melt or not. And to do that, we need to be able to know its thickness. And once we have that, then we'll be able to better assess what darkening is doing to glaciers, what contribution it's having on glacier melt, and be able to make future predictions as well. Thank you for your attention.